right, so I want to try to go through how to compare a confidence interval and a test. This isn't bad. So let's say I had this set up here, HO mu equals 10, HA mu is not equal to 10. This only works if it's not equal to. So I'll pull that. Alpha equals 0.05. So if your p-value came out to, if it came out less than alpha, what would you do? Reject HO. And does that mean it's statistically significant or not statistically significant? Can I say stat sig? Stat significant. Okay. Well, alpha equals 0.05 is the same thing as the confidence interval of 95%. And that works because these two things add up to 1. I can't highlight them both, but if alpha was 0.10, confidence interval would be 90%. That matches up with it. Like they have to add up to 1. If alpha is 0.01, what confidence interval would you be looking at? 99. So there's two ways. Another way you can make the decision. Is your X bar, let's say this, X bar is in the interval, not in the interval. Not in the interval. What would you do then? So forget we know anything about alpha, forget we know anything about tests at all. So like remove all this, remove all that. If you get X bar and if your confidence interval is like 11 to 15, X bar is not in the interval, what would you do with the original claim? You'd reject it. So if X bar is not in the interval, you reject HO, and it's, I'm running out of more room now, statistically significant. All right. If your p-value is greater than alpha, so we're back to like the test now, fail to reject, not statistically significant. If X bar is in your interval, fail to reject, not statistically significant. So they're the same like idea, just presented to you differently. So go to your Schoology, see if that made any sense or not. And you see where it says, on today's date, it says comparing confidence interval to two-sided tests. Open that, make a copy. I want you to try to fill this sheet out. We'll see if it. Make a copy and just type in your work on there. So if I were to fill in the next one, 99% goes with an alpha of 0.01. If X bar is in the confidence interval, then we think everything's fine. I would have no reason to reject HO. There's not enough evidence. It's not statistically significant, and the p-value is not less than alpha. That's like the first one you guys had to do. Is this making sense or no? Sure. Actually, hard. And a tournament in between. Yeah. Tomorrow's a really big game. Rose Hill is really good. Here. So it'll be a big one. You can't waste anything. Yeah. Pictures. Yeah, so I mean, I think it's easier to go through and like, well, if this is no, then these three are no also. But I hope you're trying to like understand also what's going on. Are we done or not yet? Not yet. Okay, that's fine. Try to like think about what's happening, not just like, oh, well, if this was yes up here, it must be yes. You know what I mean? Kind of cheat the system, which doesn't matter. Looks like you're seeing all the things. Okay. So again, these two things have to add up to 1. I know it's weird because it's like a percent and a decimal, but you know, 90% would be like 0.9, right? And then 0.9 and 0.1 add up to 1. 85% will be 0.85. So the alpha you'd be looking at is 0.15. If X bar is not in the confidence interval, so let's say we have like maybe 3 to 11 or something, and our X bar is 12, then is 12 a reasonable estimate? It's not, because it's not in this. If it's not a reasonable estimate, then we're going to reject HO. Wait, sorry. Yeah, we're going to reject HO. There is enough evidence for HA because we rejected HO. It is statistically significant, and the p-value would be less than alpha. This one would be 0.92, but then write it as a percent, so it'd be like 92%. I told you there is enough evidence for HA. So if there's enough evidence for HA, what did we do with HO? We rejected it. That means our value is not in the interval. It is statistically significant. And then yes. So 95%. And what I told you here was it's not statistically significant. P-value is not less than alpha. There's not enough evidence for HA, so we did not reject HO. And this would be, it is in the confidence interval. So if I had like 3 to 10, my X bar would be like 7 or something like in between. Is this making sense? Like to see where I'm getting this from? All right. So this would be 90%. No. 2.07. No. Wait. Yes. 99%. No. Yes. 0.1, so I told you no. 94%. No, yes. How's that? All right? Question on this anywhere? Let me undo these so I can do this again next time. And then I got a little worksheet for you. It's only 3 questions though.